This is the center of gravity model. It's actually a weighted average. And so think back in chapter 4 when we did weighted averages for forecasting, and similar to what the mean factor is. But in this case, we do have to know the sum of the weights. So the data I'm going to use is from problem 21 at the end of chapter 8. We have a chain of home health care firms in Louisiana. And these are where our home health care centers are in Louisiana. So these looks like 8 locations: Covington, Donaldsonville, Houma, Monroe, Natchitoches, New Iberia, Opelousas, and Ruston are our locations. Now, they visit, or the auditing team visits each one of the locations 3 times a year, except for Houma. They actually visit 5 times. And so these are the weights. Basically, we want to locate, you know, given the fact that we'll be visiting these places 3 times a year. Now, the way to do this is to separate, basically to look at the weighted average on the horizontal or the x-axis, and then look at the vertical or the y-axis and the weighted average of that. To see, now think about it this way. Here are all the locations. What I did is I did a scatter plot of the x's to the y's. So here is the location. This one must be the Covington, 9.2 on the x-axis and 3.5 on the y-axis. So this is the Covington location. So think about this horizontally. We're going to want to be somewhere over here in the x's as compared to being over here. The locations will pull our x up that way. And then we'll look at the y, and once again, a weighted average, we'll want to be somewhere in this vicinity because as compared to being down here, the y weights will pull us up. Now, they don't want to pull us up too high because these down here will be pulling us back and keeping us in that range. But we can do it if we just separate those two. So what you do is, let's do the x coordinate first. So I'm going to just put label this here x chord, and we'll do our y chord here. So let's multiply by the weight. So this is this amount times its weight here. So it's visited 3 times. And so we're going to do that. Now we should be able to copy that down. We'll double check that, you know, for this example, yeah, the x times the weight. Now, to figure out the final answer, we need some summations here. So we've done the x times the weight. Let's figure out what the sum of the weights are. So the total of the weights is that. We're going to need to know that. Now, so think about a weighted average when you've done it in the past. You've taken you multiplied the weight and added all those up. So we've multiplied the weight. Let's add them up now. So we will add these up. And then we will divide that total by the sum of the weights. So we're going to refer to this and divide by the sum of the weights, and that will give us a weighted average. And so what we're saying is, in regards to the x-axis, we should be about a 6. So we should be somewhere in here, and that makes sense because think about this horizontally. We've kind of split the difference between these. Now, I suspect that the one that has the heaviest weight is 7.8 and 1.4, so it's over here. So you notice they're not of all equal weight. So there are 3 that are going to be over here, and there are actually 5 over here. But that's because the Houma has 5 visits, so it's going to pull it a little bit higher normally, and so 6. So that makes sense. you should be able to step back from your answers and say, well, would that be a reasonable answer? Now let's do the y coordinate. Same thing. This time we're going to look at it vertically. So we're going to just look at the y coordinate times the weight. And once again, we'll do that for all of the locations. We'll multiply it by the appropriate weight. And then we're going to do a sum of that. Just like we did with the x-coordinates, we'll sum those up. So we multiply by the weight, add them all together, and then we divide by the sum of the weights. And the sum of the weights is still the same. And we get, oh, what did we do wrong here? Here's a good example of something that doesn't make sense, 22. So let's go back and make sure we double check the y times, oh, there's the mistake. Let's go back here, and I was multiplying the y times the x-coordinate. Need to do it times the weight. So there's my mistake. So or the y times the weight, not, so now we'll copy that down. Let's double check now that we got it right. Yeah, so we have the y coordinate times its appropriate weight, and we have the sum total, and this answer now makes a lot more sense to us. So just double checking down here at the bottom, the y coordinate times the weight, and then of course this is the sum total of that, and then we divide by the sum of the weight. So we're going to say it's 4. So the ideal location, now we could look at this in isolation too. So we said it was 6, and we would say it is a little over 4, so right about here. So once again, it makes a lot of sense in that vertically, where we split it, now you'll notice that we don't go, part of it is we're not up here, we're down here, but remember that the one location where there are 5 visits is going to put a little heavier weight to pull us down, and there are more locations down here. These will pull up, vertically a little bit. Otherwise, it would be down here even closer in this mix. But because those are up there, it's pulling up a little bit, but it can't pull it way up there. So the ideal location, we would say, would be right. So 6 and 4, that's where we should put our location, right in that spot, because that would balance then us traveling in between all these locations, and that's the center of gravity model.